All right, thumbs up. Hello, everybody. I am happy to be here and a little terrified after following the presentations earlier, but let's see how I do. So the purpose of my talk is I'm going to show you 25 visualizations real quickly, and we're going to talk about when to use them. But first, I'm going to show you pictures of my family and my dogs, because I'd be a lot happier right now if I was talking to you about clicker training or about dogs or about how awesome my wife is. But I don't think that that would be an appropriate topic for PLOTCON. So unfortunately, I'm going to just talk about data viz. And hopefully you'll enjoy it and get something out of it. Just a little bit about background. So I've been doing computer stuff for a really long time. In the mid-90s, I started working on supercomputing. I hired my first ML engineer in 1999. I've been working in automation and robotics and data science really for my whole life, it feels like. And in 2015, I joined full-time as the chief data scientist at Domino Data Lab. If you look at this, you'll notice there's one thing that isn't listed on here, is anything about data viz. I don't actually really know anything about data viz, it turns out, other than what I've had to pick up in order to communicate and to get through the difficulty that is the conflict between people's ideas about what they think is and what the data actually shows. So when a couple of months ago, Anna, one of the conference organizers, was like, oh, hey, Ed, you're a good speaker. Why don't you come talk to PLOTCON? I was like, oh, sure, that sounds fun. You know, I imagine like it'd be nice and serene, and I imagine it would probably be a conference with a bunch of different tracks, and people would see my really basic talk, and they'd be like, oh, fortunately, a fun, easy talk that isn't going to really challenge me a whole bunch. And then a couple of weeks ago, I was reminded by an email, it's like, hey, PLOTCON's coming up. And I was like, cool, let me check on the website. And it felt more like this. It felt like, oh no, what a disaster I've walked into. I mean, it's going to be okay, but I mean, it really like, it was one of those things that like I had this serene idea and then boom, volcano. It's a single track talk, and on top of that, this is the schedule, Ed. You know, it's this is how you're going to be following. The day's going to start out with God herself. She is going to be presenting, and she's a fantastic speaker, an incredible educator, and she's going to be talking about data viz and stuff. And then we're going to follow up with the guy that God asked for data viz advice. And that's what's going to happen next. And it's going to be just fine. And because the next thing that's going to happen is this guy. You're going to follow up with this guy, some sad clown that nobody's ever heard of. But no, so here I am, your sad clown. The show must go on. So I'm going to talk to you a little bit about data viz. I'm going to talk to you a little bit about Domino. Very little. It's going to be like 30 seconds worth of product pitch. And a little disclaimer, I'm not a data viz expert. I was at a data generalism conference a couple of weeks ago, and we were talking about like visualizing networks and visualizing relationships. And that's when I realized that like all I really know, the little that I know, is like visualizing tabular data, you know, data that's like already in like columns and rows, and it's all convenient and easy. So I'm not going to be talking about any of the hard data viz stuff, mainly because I would be even more incompetent than I am already. So I will talk a little bit about maps at the end, but it'll be real quick. So if you wanted to learn anything about non-tabular data, go somewhere else or like Google while I'm talking. It's cool. Like my feelings won't be hurt. It'll be okay. Also, I want to point out that I'm like not a brilliant data viz thinker. Like I'm not like Hadley, who's like invented literally everything I'm going to talk about or anything like that. This is just stuff I've like picked up, right? Dr. Andrew Abella's extreme presentation method in like 10 years ago was the first thing that I was like, oh, you mean that you don't just like pick whatever chart Excel tells you to use? You can actually like use your brain and pick a visualization. And then the folks at the Financial Times have done this incredible work with their Chart Doctor feature. If you're not already like reading the Financial Times Chart Doctor stuff, you really owe it to yourself. It's pretty fantastic. You know, I'm standing on the shoulders of giants and kind of like stealing from them a little bit and pretending like it's my own stuff. So yeah, these are the folks who I'm really leveraging here. Real quick, I wanted to talk about Domino. Domino is is who I work for. All of the visualizations I'm going to show you. This is the Domino project that has the code that actually like generated them for the ones I didn't just blatantly steal off the internet, which is like only like one or two of them that I couldn't quite figure out how to like make work right. Domino makes it really easy to like run code and then have people like look at what you ran and what was installed. It makes it really easy to manage package versions, which was an interesting question, but that's sales pitchy, so I'm not going to get into that. What I am going to get into is what are the categories of data that you want to visualize? So this is how I'm going to really start my data viz portion of my talk. Whenever you have data, data's unkind, right? It's just a bunch of bits and bytes loaded in arbitrary areas of memory in your computer. We overlay on top of them sort of this like conceptual framework of like, oh no, these columns, they mean dates, and these columns, they mean quantities. But on top of that, you have to apply the lens of reason of what you want to extract from them. So I'm going to talk about 7 categories of visualization in my remaining 22 minutes somehow. I'm going to talk about deviation. That's when you've got some idea of what you want as the normal thing and things go to the left or to the right. Correlation, right? If you pull on a pulley and a thing goes up, you want to know what is the relationship between pulling on the pulley and the thing going up. Ranking, this is the thing my wife is constantly doing where she's saying, well, you did worse this day than this day, or you did better that day than this day. Sometimes it doesn't matter actually like what the value is, it just matters what it is compared to the other values that you're comparing about. And distribution, we're going to talk about when you look at the population as a whole, like what's the shape of the thing? Like how many, when you look at the individuals and you put them into buckets, like how many tall people are there, how many short people are there, how many fat people are there, how many thin people are there? That's the distribution of a population. Then we'll talk a little bit about change, which is like, it would be really, really nice if data just stayed the same forever and we never had to worry about things changing over time or changing as you apply different lenses, but that's not our reality. We'll talk a little bit about composition for a minute, basically, which is like you've got a whole, and holes are made up of parts, and you want to talk about them parts in an interesting fashion. We'll just show a couple of visualizations about that. And then we'll finish off with some spatial data visualization, because we're humans made out of meat living on a ball flying through space, and that is like a ball in space, and sometimes it matters where on the ball you are and where on the ball things are happening. So it's good to be able to visualize those things. So, all right, we'll get moving right to deviation. So now I'm literally just going to slide, visualization, what I think it's useful for, next slide. So let's see how this works out, because I've never done this before. Diverging bars. So this is a good visualization to use if you've got some categories of stuff and it's a small number of categories and you've got a mean value of some sort or a reference value, and you want to show how these particular categories diverge from the value that you consider a reference or good value. These are useful like comparing like classrooms and teachers when compared to a state average or something like that. Spine charts. These are really great for like, I don't know, like let's say some hypothetical scenario like you've just had a really contentious election in your country and you want to talk about how different groups of people voted for different folks or how they, how they supported different areas. Just hypothetically speaking, spine charts are really, really good when you want to have this duality between two separate groups and how they felt about things. Area charts. These are fantastic and pretty straightforward. I mean, let's say that you've got some baseline like this, like the S&P 500, and you want to talk about how an individual stock performed compared to that particular baseline. Area charts are fantastic. At a glance, you can tell that they go above, that they go below. It doesn't require a lot of interpretation. One of the characteristics of a good chart for me is that like you can look at it and you can just kind of get it. Area charts are fantastic for understanding deviation when it comes to moving across time. Correlation, let's talk about that. So this is what I was talking about, the pulleys. When you pull on a pulley, something moves. You want to understand what the relationship is between a change in one thing and changes in other things. The canonical example of correlations is the scatter plot. Everybody's used it. I don't know about you, but whenever it is I start some data analysis, I'm going to say 9 out of 10 times I'm just jumping into a scatter plot because it's just like the most obvious, fantastic way to visualize these things. Like height versus weight, age versus income. Anytime you're talking about numeric thing versus other numeric thing, and there's two things, you probably want to reach for a scatter plot. But sometimes you're talking about numeric thing, and another numeric thing, and a category. And that's a lot of dimensions in a data set right there. For that, you want to use bubble charts. They're like scatter plots, but they add like, you can have like the size of the bubbles matter and you can color them and like you can have like blue and red and like blue means one thing and red means another thing. These are fantastic, like I said, when you've got maybe 3 numeric things you care about and you've got 1 categorical thing that you care about. This is fantastic. One of the ways I see bubble charts misused, well, I won't say misused, that I think is not intuitive, is when you've got 4 numeric dimensions and people will like color it with a gradient. That's really, really hard. Like gradients are really hard to compare. So don't do that. If you're going to use color, make sure that you're using color sparingly and it's tied to some like categorical thing that can make a lot of sense. And then, because we haven't talked enough about Hans Rosling in this data set yet, you've got animated bubble charts. Is it actually animating? Oh, it is, yay. So animated bubble charts are when you're like looking at 5-dimensional data and you're like, how do I want to make it both incredibly compelling and really, really hard to follow at the same time? Animated bubble charts are really, really fantastic for that, right? You can show macro trends, you can get a lot of information out of them, but like, I don't know about you, like, you know, whenever I saw that TED Talk, you know, the Hans Rosling TED Talk, I think it was a TED Talk that Hadley was talking about, like, that's one of the things that was like, oh, wow, DataViz is awesome. And then I, like, tried to use it myself, and I realized that anybody I showed it to them, I had to spend 30 minutes trying to explain, like, what the animated bubble chart was doing, so, like, maybe not so hot. I don't know. Next, we're going to talk about heat maps. Remember, so we're talking about correlation. So what are heat maps good for? Let's say you got a ton of categories, like a stack of them, like the number of, like the teams in a baseball league or countries, and you want to compare some numeric quantity for one of those, for those categories against some numeric quantity against all the other categories. Heat maps are awesome, except for the fact that they're completely uninterpretable. The cool thing about them is that if you're really smart about ordering the rows and the columns, you can show really interesting macro patterns. But like, if I tell you like, oh, what's the difference like row 1, column 2, and row 4, column 5, you're like, well, one is like slightly more bluish than the other, maybe. You're not going to have an idea as to really like what the values in them are. So use them sparingly. Like, they're really good for presentations and looking smart to your boss, but the communication power of them is actually pretty minimal. So then we get to ranking. All right, so what are we talking about ranking? This is when an item's position in an ordered list is more important than an absolute or relative value. You know, this is pretty important. Don't be afraid to highlight one of them if that's the one that you really want. The standard ranking that pretty much everybody uses is just an ordered bar chart, right? Like, it's pretty easy, it's pretty straightforward. Like, you can look at it immediately and go like, the bar on the bottom is longer, therefore it is more. It's not gonna take you all day to figure this out. They're really easy. I mean, yeah, there's basically, this is one of those like no downside visualizations, which is completely different from ordered column charts. Never use these are garbage. Then you go to slope charts. Slope charts are one of my favorite ways of showing ranking because they're a static chart that basically shows you the ranking at one point in time and the ranking at another point in time. It's a fantastic way of taking this like data and seeing basically, you know, but yeah, like the before and the after, and you can see like, oh, things that were in the top are now in the bottom. When you start actually Googling how to make slope graphs in ggplot, you will find that it seems to be that at some point around like 2012 to 2013, everybody decided to invent how to make these slope charts in ggplot, me included. There's lots of competing ways to do it. If there's an official way to do it, Hadley will nod at me. No, there isn't. Excellent. So invent your own, and maybe it'll become the official way to do it. But there's a problem with slope graphs, is that they can become this really, really, really quickly, which looks super duper cool, but is utterly and completely uninterpretable. Like, these are like spaghetti graphs. I don't know what I'm supposed to get out of this, other than the fact that, you know, tempus fugit and everything is cruel. So yeah, with great power comes great responsibility. If you've got to do something like this, don't use a slope graph. Probably don't actually visualize this at all. Like, there probably needs to be some narrative using words and lots of hand waving that goes around with this. And finally, for ranking, I like lollipop charts. I mean, they're just bar charts, right? Like, let's not kid ourselves. Like, they're like a fancy, like, modern Dutch version of like a bar chart. But like, they look really nice, and they really highlight the point that like, you've got like, that's the data point. I think they're very attractive. They're relatively straightforward to do. And like, sometimes you're bored of making bar charts. Well, reach for a lollipop chart. The ranking isn't explicit. It's easy kind of to see with the point of the data. Life is pretty straightforward with these. All right, let's see, how am I doing on time? Oh, I'm going too fast. Oh, well, we'll get to lunch earlier or something. All right, then we talk about distributions. So this is what I was talking about. This is the shape of the data, right? So the shape of the data is important whenever it is that you're talking about lots and lots and lots of data, and you want to actually like get some idea about, when you look at it all together, like, you know, how does it all behave as one? And there's kind of like a canonical, right, like distribution, like, because maybe you want to see the skew. Is it all to the left? Is it all to the right? Is it like, does it fit a distribution that you really wanted it to? And for that, you're just going to reach for a histogram. I actually said in an interview once that I'm kind of convinced that data science is like 85% histograms. I actually stand by this idea. Like, it's one of those things that like, there's so much information like conveyed inside of a histogram. It's like one of the most powerful like dimensionality and magnitude reduction techniques that like money can buy. It's immediately interpretable. It's like 18 characters of code to like get a beautiful histogram that'll impress your boss. So yeah, leverage them whenever it is that you've got some like single series of data that you want to show the shape of it. Lots of people will like try to do histograms with lots of series of data, and they'll like overlay histograms with alphas and opacities on them and like do color stuff. If that's what you find yourself doing, like actually like take a step back and try to like think like, what is the actual information I'm trying to convey, or am I just trying to do a pretty thing? Because I really believe that like the beautiful thing about histograms is their simplicity, and when you start layering them and adding funny hats on them and stuff like that, that's when life can get pretty confusing. And if you want to do that, right, like let's say, oh, but I actually do have like 2 or 3 series of data and I actually do want to show their distribution, congratulations, there's a thing called a box plot. I'm always surprised at box plots. Like it's one of those visualizations that like every time I use it, I'm kind of like shocked at how much information is encoded in a box plot. You're like inside of one of these things, you're like showing the min, the max, the like the mean, you're showing the shape. They're so powerful and so immediately not immediately. Once you've learned about them once, like they're so intuitive to understand. Good examples of these, like the canonical example is stock data, right? Like high, low, close, all that stuff. But you can find all kinds of really great uses for these, and I really suggest that you find ways to use them. I think they're underused, but whatever you do, I think, don't use violin plots. Everybody that like learns about box plots immediately is like, oh, but I lose the shape of the data and the shape is awesome. And then they like find out about geom violin and they're like, oh, violin plots are so cool. Only nerds understand it. Like nobody's ever looked at a violin plot and like actually gotten like a whole bunch of like new information out of them, right? Like you look at a violin plot and you're like, oh yeah, that one's like bumpier on the left, I guess. Try to imagine what your reader is thinking. Like try to actually like, be in their shoes. Like they don't care that you knew how to use geom violin. They just want to know if they should like make a decision. And I don't believe it actually conveys a lot more information. I'm sure there's a fantastic example of when to use geom violin charts, and I'm sure one of you will like make fun of me afterwards for not knowing it. I just haven't learned about it yet. And so to finish up distributions, you have population pyramids. I like population pyramids because they remind you that you're going to die, and I think that that's important. They're like this fantastic way of visualizing, like, you've got this population, and like as time goes on, like there's less of them, and like you can visualize, like in the Gapminder data set, you can visualize like terrible things that have happened in society or great things that have like expanded the life expectancy. My favorite thing about them is that like somebody out there like made their career out of inventing the population pyramid. Like somebody out there's like, I'm the population pyramid person. And like all they did is they just like took a histogram and took another histogram and like duct taped them together, and they were like, bam, population pyramid. Which I think the most important lesson there is, hey, you, people in the audience, like figure out what visualization you can duct tape to another visualization and give it a name, and you too can data viz famous. Like, yeah, go out and do that. Let's see, so then we get to change. Okay, we're at 5 of 7, we're moving along. So change is important because it's like the one constant, right? And it's hard to visualize. Usually people want to think about visualizing change and they think about animation and they think about these things. You don't have to go that hard. Like the best visualization of change is just the humble line chart. I love line charts, and like they're the most misused visualization I see out in the field. Like I go talk to like customers and people, and like they'll show me like their sweet dashboard, and like it's a line chart that's just like one spike, then nothing, then like a second spike, and then nothing. And I'm like, well, like your x-axis, they're like, oh, it has like 5 points on it. It's like, no, that should have been a bar chart. Line charts are fantastic when your like x-axis has a lot of numbers in it. There's a series. It's a continuous value. Don't misuse this thing. Yeah, that's what I want to say. It's got to be pseudo-continuous, but it's so powerful. Like my like little kid, when he was tiny, I could like be like, hey, Nathan, what does this mean? And he could get it, or he could be like, oh, well, here it went up, here it went down. That's the kind of thing you want to be striving for in your data viz when you're talking about something as complex as change. The neat thing about these are fan charts, right? Like because like, let's say you're looking backwards in time and you've like got actual data about what done really happened, and then you've got this sweet model that predicts what's going to happen. You want to have some way of like showing the difference between the stuff you know and the stuff that you're making up. And yeah, exactly, like the guy over here is like, right? You've got to be able to do that, because when your boss comes up to you and says, hey, your line chart showed that we were going to sell 7 and we sold 3, you want to be able to go, no. that was in blue. That was a totally different thing. You want to be able to get away with that, right? Like you need that plausible deniability. So use them. I have it on good authority that a lot of data science interviews, friends of mine, like when they interview folks, like that's their big test is like, do people actually show like confidence intervals in their visualizations? So like, use them. They exist for a reason, as we learned recently in this hypothetical scenario I was talking about. Turns out confidence intervals matters. But let's, this is all for a single series, right? Like we talked about a single numeric series as it changed over time. And then we get like, well, what if you want to talk about lots of things changing across time? Ah, well, cool, you can use like this concept called an area chart, and it's stacked, and it's beautiful, and I'm using opacity, and it's completely uninterpretable as far as I'm concerned. There's no actual way of like knowing like 3/4 of the way through if like the fifth thing is fatter than the one on the bottom. Like human eyes and brains are kind of like dumb, and like they're good for like, using a stick to like get a caribou. They're not really good for like showing the different sizes of different things across time. I'm sure there's a fantastic scenario for these. Like this is one of those things where like, and maybe if you're using a proportional stacked area, you want to show like the percentage of like the amount of the market that you owned over time and it's growing, like it can be useful. But aside from like really, really narrow scenarios, if you're like reaching for these like stacked area charts, make sure you're super, super confident that you're doing the right thing, because otherwise, not so hot. So as I mentioned earlier, we're like human beings made out of meat in this like blue-green sphere flying through space, and that isn't terrifying at all. And like the sphere is rotating around the sun, and it's rotating around itself. And so we decided at some point that we were going to come up with this idea called days and the calendar, and we were going to use it, and we were all going to agree that this was meaningful. And it's, I think, the last great innovation that we came up with, except if you've ever had to program date-time variables and you've realized that like abstractions are leaky and garbage. However, it's still like the most meaningful thing. Like your boss like wants to know what happened last Wednesday and last month, and like people want to know like what after some treatment went into effect, how did it affect some numeric thing. I really like, this is like the one example of heat maps that I really actually like is the calendar heat map. It's really useful because it's like immediately intuitively obvious. Like if somebody sees April, May, or June, they're not going to be like, what on earth are those? Like people know what April, May, and June are, and from there they can get macro patterns. Again, it still has the same failure modes that the other heat maps have, that like, hey, like the 4th week in June, how is that compared to the 5th week in July? And you're going to be like, it's like orangey-ish, and that's not like the most scientific thing that you could come up with, but at least there's some value behind it, right? So reach for these whenever you need to visualize a trend across time, and you need to be able to like attach it to a calendar that people are actually going to understand. All right. Wow. Composition. So we're whole beings, and we're made up out of stuff, and that's kind of the way our universe and our reality is shaped, that it's made up of stuff. And sometimes you want to show like that whole thing. What are the things that make it up, right? The only one I really like is the stacked column. It's just immediately kind of intuitive, right? Like you use colors, you can see, oh, here's a column, and like there's a little sliver of this blue thing and a big sliver of this green thing, and it's pretty fantastic, and it's super duper versatile, right? Because you can have like multiple columns, so you can like show across time how like this thing changed, or for particular categories, like what are those categories themselves made up of? It's really, really powerful. The neat thing about it is you can also simplify it, and you can just have a single column, and it can be the size of the entire plot, and you can just be talking about percentages of a thing. This one visualization is pretty much all I've ever needed for showing composition. The one data viz that really, like, there's only a very, very select scenario that you should use is the pie chart. Use it when you're talking about pi. Really, that's about it. Aside from that, like, and some people will be like, oh no, it's like really good when I'm like, I've got one big thing and one little thing. And they'll try to convince you that it's okay in that scenario. Those people are your enemies. Don't be friends with them. They're trying to betray you. Like, they absolutely are. Like, take it from me. Again, if you've got some scenario where a pie chart is totally better than this chart, I want to talk to you, because I want to know that you're my enemy and I want to have eyes on you. Aside from that, though, there's really no good reason to use this. And this is one of the charts that I loved for so long. I loved waffle charts because they were so visually appealing, and like they're cool and they're hip, and they've got like that minimalist Dutch feel to them. And like, oh, you can show the composition of a whole, and they're really, really nice. And then I showed my kid a waffle chart, and I was like, hey, Nathan, blah, 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 blah. And he was like, couldn't you just show me 4 numbers? And I like looked at it, and I was like, well, yeah, I guess, but then it wouldn't look so cool. And he was like, this is what you do? This is how you like afford the house we live in? The answer is I do many things, Natha, many things. So waffle charts, maybe there's a really great use for them, like they can be maybe striking in a presentation. Ever since my kid pointed that out, though, I'm kind of pretty sure that, yeah, you can kind of just use 4 or 5 numbers because, like, those are pretty immediately intuitive. And wrapping it up, let's talk about spatial data. Again, blue-green sphere, meet people, flying through space. Sometimes we need to talk about what it is that is going on in particular areas of our meet space world. And like, you want to be able to visualize it with some data. There's this amazing package that came out this year called Tilegramzer. Not real good at pronouncing that. It's this amazing way, like so I'm from Spain originally, and Spain's a little country, and it's kind of uniformly, densely sort of populated, so we don't have these problems. But if you've ever like been in the United States, particularly in the middle parts, ain't no one there. Like, there really isn't. So like, whenever you visualize things like just taking the geography into account, like it's just misleading, right? Every map ends up becoming just a heat map of population density. Yeah, population tiles are fantastic if you want to like take the United States and actually like represent where people live and like what they're doing in those places. Like, it's really fantastic, but sometimes you don't. Right? Sometimes you don't actually care about the population because what you care about is how different regions actually communicated. And that's when you can use these like region hexes. I really like these as well. What I really like about it is that like Florida is almost like not even really noticeable here. Like, you can barely tell it exists, which is the world I want to live in. And, but it's still kind of, it's a powerful visualization, right? Like, you can sort of understand the regions, and it gets you to understand like, province or state level analysis. It's pretty powerful for that. It's a lot better, again, I think, than just using a straight actual like map that you like color little dots and you're like, well, that's where Miami is and that's where Los Angeles is. I didn't know that. Thank you, data viz guy. And then finally, my final visualization that I'm going to show for spatial is heat maps. Sometimes these are actually useful. This was an example I found. This is one that I just straight up stole off the internets. It's just the density of, what was it, gas stations in Germany. I don't know why there's so many gas stations on the left. Somebody from Germany can maybe tell me, or maybe it was just a bad data viz and I got fooled. These are really, really good if that's what you want to show, right? Like, if you actually, what you really actually care about is, given the true geography of a place, the actual placement or location of individual phenomena. This is kind of like the one scenario where this can matter, but again, be really careful that it doesn't just end up being a histogram of, like just a map of population density. That's what really usually ends up happening. But maybe that's what you want to show. Maybe you really want to show that, like, it turns out New York and LA are where people live. Who knows? All right, so in conclusion, there sure are a lot of choices. I don't know that anybody learned anything, but at least I'm wrapping up, right? So you can't, you can't just pick the prettiest one unless that's your goal, is to pick the prettiest one and not communicate, which is, hey, good for you. I'm not telling you how to live your life. You want to understand what you're trying to convey, and you want to actually make some principled choices about this sort of thing. It's kind of the difference between effective and non-effective data visualization. There was a long time ago where I thought like there was like 3 visualizations and that was all that we needed, like the way the good Lord intended. You had a line chart, a bar chart, and a pie chart, and that's the world that you were going to live in. Turns out that's not the world you're going to live in. There's like this wide assortment of ways that you can visualize data, and people are coming up with new ones every day. So you want to make sure that you've got sort of a good framework for understanding, hey, what is the thing I want to talk about? Do I want to talk about, like I said, do I want to talk about change? Do I want to talk about distribution? What is it I want to talk about? And pick a visualization that really actually resonates with that. And with that, hey, thank you very much. I hope you got something out of this. Thank you, Plotly, PLOTCON, and Anna. This is the URL for the code. See you all around. Thank you.